In all of the previous videos, we've considered the slope-intercept form of the line, which we abbreviated as y equals mx plus b. So if you are given the slope and the y-intercept, you can come up with a relationship. In other words, you have numbers for those, like y equals 3x plus 2. We now have a relationship between x and y. What we want to cover now is the general form of a linear equation. So in the general form, we write it as ax plus by equals c, where a, b, and c will all be numerical values. So let's write in an example. Let's consider 2x plus 3y equals 20. So we now have numbers for a, b, and c. So we have a relationship between x and y. It's different because x and y are both on the left-hand side of the equation. Now, first of all, why is this linear? Note that the exponent on x would be 1, and the exponent on y would be 1. We typically don't write those in, so we would leave those off, but you have, whenever the exponents on all of the variables are 1, then you know that you have a linear relationship between the variables. So seeing it in this form tells us that it must be linear, even though y is not on one side and x is on the other. Now, what is the value of having this form? There are certain things that we can do very quickly in this form. So for instance, we could set x equal to 0, and immediately we know that 3y should equal 20. That means that y would be 20 over 3, or 6 2/3. So what did we just find? We found the y-intercept. Okay, when x equals 0, we're on the y-axis, and so 6 2/3 is right there. So we now have the y-intercept. We can quickly, though, turn around and do the following. We could set y equal to 0 instead. So there's more symmetry here. We could set x equal to 0, or we could set y equal to 0. When we do that, we know that 2x must equal 20. Therefore, x is 10. What did we just find? We found the x-intercept. This is when y equals 0, we're on the x-axis, and x must equal 10. So now you could sketch in the line between those 2 points. We've defined the linear relationship because we have 2 points, and our line looks something like this, of what we just sketched in. Now, why might this be useful? Let's consider a word problem where this would be advantageous to have this form. Let's consider a word problem where flour costs $2 per pound. Cornmeal costs $3 per pound. And let's add in, you spend $20 on these items. The relationship that we have, 2x plus 3y, defines that completely. We could, according to what we have first figured out, if we let x be the amount of flour that we have, we could buy no flour, and we could buy all cornmeal. We could let y equal the amount of cornmeal that we buy. And if we buy no flour, we could end up getting 6 2/3 pounds of cornmeal. On the other hand, we could use what we already know. We could buy no cornmeal. And if we buy no cornmeal, we can get 10 pounds of flour. But consider all of the other points on the line. There are an infinite number of possibilities of combinations of flour and cornmeal that we can get. Okay, so this point right here shows us that if we get a little bit more than 5 pounds of this was flour on this axis, we can get somewhere between 3 and 4 pounds of cornmeal as well. We could figure out the exact point on the line by either putting in an amount of flour and determining how much cornmeal we could have, or vice versa. So it would be very useful because now we have all of the possible combinations of flour and cornmeal that total $20 of value. Later on, we can look at what would happen if we limited ourselves to $20 of value. Clearly, we could buy no flour and no cornmeal, but it would turn out that we could buy anything within the triangle created by the line. Now, the final thing we need to do is understand if the general form is linear, how does it relate back to the form y equals mx plus b? So let me clear everything out. Let me rewrite the equation. 2x plus 3y equals 20. And now let's try to get it in the form y equals mx plus b. What this means is we have to solve for y in terms of x. So we have to isolate y, get it by itself in order to solve for it. And we would like for it to then be in terms of an expression that has x in it. So to do that, the algebra is pretty simple. If I subtract 2x from both sides of the original equation, I'm getting closer to having y by itself. I now have 3y on the left side, and I have negative 2x plus 20 on the right side. I can now divide both sides by 3, and y will end up equaling negative 2x, 2/3 of x plus 20/3, which is also known as 6 2/3. So we get the same y-intercept that we got in the previously. We determined that this is 6 2/3, which is what we had gotten before when we substituted 0 for x. Just real quickly, let's consider one more case. What happens if this had been 2x minus 3y equals 20? If we wanted to solve that one, we would do the same first step, subtract 2x from both sides. But now we would have the negative of 3y equals negative 2x plus 20. We would have to divide both sides by the negative of 3, and just be careful when you have negatives. A double negative ends up giving us 2/3 for the slope. And when we divide 20 by negative 3, we have to make sure that we get a negative result, and so we get negative 20/3. So in that case, the line would slope upward rather than downward. A final note, when the signs are the same for the two coefficients, so in the first case that we've been working with, it was positive 2 and positive 3, we actually ended up with a negative slope value. When the sign was different between the two, we ended up with a positive slope value. So that's useful when you're looking at a general form. When the signs are the same, you have a downward sloping line. If the signs are different, you're going to have an upward sloping line when you convert, when you plot it.